built into America. Caracas, Venezuela. A normal evening. 8 million people going about their lives. No one looking at the ground beneath their feet. June 24th, 2026. 9:47 p.m. The ground moved first, a low rumble. Then everything shook. 8 stories. 40 years of concrete and steel. It took less than 10 seconds to come down. It was caused by a decision made decades ago about what was cheap enough to build. In an under-reinforced column, the concrete can't flex. It shatters. The column fails catastrophically. And when one column fails in a multi-story building, the floors above have nowhere to go but down. On June 24, 2026, 2 earthquakes struck Venezuela 40 seconds apart. Magnitude 7.2, followed by 7.5. The ground moved for less than a minute.
This wasn't an accident. It was a failure of design.
The exact same magnitude, yet the outcomes could not be more different. 0 collapses in Japan versus 1,400 buildings destroyed in Venezuela.
Examined the rubble, they found what they expected and what they feared. Columns with rebar spacing twice the safe limit. Concrete with aggregate too large for structural use. Connections between floors and columns that relied on gravity, not engineering. Concrete without adequate steel. In a properly reinforced column, seismic force travels through the steel. The column bends slightly, absorbs the energy, and returns to position. Engineers call this ductility. It's the single most important property in earthquake-resistant construction. This is called progressive collapse. One floor drops onto the next. The impact doubles the load. The next floor fails. In a building with insufficient reinforcement, the entire structure can pancake in under 10 seconds.
We got movement over here. Keep cutting, we're almost through. Careful, it's unstable. As you can see here, proper reinforcement utilizes this triangular structure. Insufficiently reinforced structures, however, often rely.
From Mexico City in 1985 to Haiti in 2010 and 2023.
Contractors and developers were arrested in Turkey after the earthquakes, charged with causing death through negligence. The buildings they built became their indictments. But the problem isn't limited to developing countries. It isn't limited to places with corruption or weak enforcement. If you're watching from the United States right now, what I'm about to show you is closer than you think. The buildings that collapsed in Caracas shared a specific design. Thin concrete columns supporting flat slab floors with no edge beams. This design is efficient, it's economical, and it is catastrophically vulnerable to horizontal seismic force.
This represents the gravity load, supported and perfectly stable. But introduce a lateral force, and the entire system fails.
Now you understand why 1,400 buildings in Caracas collapsed in less than a minute. Not because the earthquake was unusually powerful, because the buildings were designed for a world where earthquakes don't happen.
This is the crucial piece of evidence they didn't want us to find. And I promise you, it changes everything.
Welcome back to our investigation. Click subscribe to follow every lead.
Urgent. Caracas is 2,000 miles from the nearest American city, but the engineering failure that killed 920 people that night exists in a different form much closer to where you're sitting right now, and it's been there for decades. Let me take you to a specific address, a specific earthquake, a specific failure that America was supposed to learn from. January 17, 1994. Magnitude 6.7, smaller than Venezuela. The result? 57 dead. $38 billion in damage. 120,000 people displaced from their homes. A 6.7 is not a catastrophic earthquake by global standards. Japan experiences dozens of them. Why did this one cause $38 billion in damage? The answer is hiding underneath thousands of California homes right now. And it has a name. Engineers call it the Cripple Wall. 70s. From the outside, a cripple wall looks structural. It's made of wood studs. It's framed properly. To any homeowner, it looks like part of the foundation. But it has a critical flaw that only reveals itself during an earthquake. A cripple wall built without structural plywood shear panels has almost no resistance to horizontal force. The studs are designed to carry vertical load, the weight of the house above. When the ground moves sideways, the wall has nothing to prevent it from folding over. The wall folds. The house slides off its foundation. Not dramatically. Not like Caracas. Quietly. The house shifts 6 inches, 12 inches, sometimes 2 feet. And when a house moves 2 feet off its foundation, every gas line, water line, and electrical connection shears. That's when fires start. After Northridge, more than 100 fires broke out in the first hour. Many of them started when houses shifted off their foundations and severed gas lines. The earthquake shook the house. The cripple wall failed. The gas line broke. The fire did the rest. And here is what a retrofitted cripple wall looks like. Structural plywood nailed to both sides. Anchor bolts connecting the wood sill plate to the concrete foundation. Steel hold-down brackets at every corner. The same wall, the same house. Completely different outcome. The cost of that retrofit? $3,000 to $7,000 per house? The cost of the damage it prevents? Potentially everything you own. Northridge happened 32 years ago. The engineering was understood. The retrofit was developed. The question is, what changed since then?
Following the 1997 update, new
The honest answer,
mandated anchor
the building
bolts
code
and
was
shear
updated for
panels,
new construction.
making buildings
Houses
safer.
built after 1997 in California require anchor bolts, shear panels, and hold-down brackets. New houses are significantly better, but existing houses, the 3 million homes built before 1980 in California alone, were not required to retrofit. The code was updated going forward. It was not applied backward. In the San Francisco Bay Area today, there are approximately 140,000 residential units in 18,000 soft-story buildings. Buildings with open ground floors, parking garages, retail spaces, and apartments stacked above. A soft-story building is exactly what it sounds like. One story, usually the ground floor, is significantly weaker than the others because it has large openings and few or no shear walls. The apartments above are rigid boxes. The ground floor is an open cavity. When the ground shakes, the ground floor collapses and the upper floors drop. This is exactly what happened in San Francisco's Marina District during the Loma Prieta earthquake in 1989. Soft-story buildings pancaked at the ground floor. Upper stories dropped onto crushed cars in the parking below. The images defined that earthquake. There are still more than 6,000 unreinforced soft-story buildings in San Francisco alone. 6,000 buildings in a city that sits directly on the San Andreas Fault. San Francisco passed a mandatory soft-story retrofit ordinance in 2013. It requires owners of these buildings to install steel moment frames or plywood shear walls at the ground floor. The deadline has been extended multiple times. Compliance is still not universal. But let me widen the map, because this is not just a California problem. The United States has significant seismic risk in places most Americans don't associate with earthquakes: the Pacific Northwest, the Cascadia subduction zone, the New Madrid seismic zone in the central United States, Charleston, South Carolina, Alaska, Hawaii. The largest earthquake in American history didn't happen in California. It happened in Missouri. In 1811 and 1812, the New Madrid Fault produced 3 earthquakes estimated above magnitude 7. They rang church bells in Boston. They reversed the flow of the Mississippi River. Today, the New Madrid zone underlies parts of 8 states: Memphis, St. Louis, Nashville, Little Rock, cities with millions of people, cities built almost entirely of unreinforced masonry and wood frame construction. Tennessee last updated its seismic building code requirements in 2009. The state sitting on the most dangerous fault zone in the eastern United States is using a building code that is 17 years old. The Cascadia subduction zone, running from Northern California through Oregon and Washington to British Columbia, is capable of producing a magnitude 9 earthquake. The last one occurred in 1700. It's overdue. Portland and Seattle are built predominantly of wood frame construction on soft soil. Many homes are pre-1980, with no seismic retrofit. When Cascadia ruptures, not if, when, the damage projections exceed anything in American earthquake.
13,000 deaths, 27,000 injuries, 1 million thousands and displaced. Oregon and Washington alone.
He claims he wasn't there that night. But the forensics prove otherwise. We know exactly what he did.
We trusted the evidence, but someone deliberately erased it and let him walk
The
free.
code is designed to a life safety standard. That means the building should not collapse immediately, so occupants can escape. It does not mean the building will be usable after the earthquake. It does not mean the building won't be a total loss. Translation: your house can be completely destroyed.
Earthquake damage is excluded. It requires a separate policy. Few Californians have coverage. The rest,
We thought we knew exactly how it happened.
The code kept you alive.
But this new piece of evidence changes everything. To the untrained eye, these 1960s homes look perfectly solid. But beneath the surface, each one is a potential failure point. Was it built before 1980 in California, Oregon, Washington, Nevada, Utah, Alaska, or Hawaii? At this point, we have to look past the emotion and focus purely on the facts.
Without retrofit. Up to now, I've been talking about the past, about disasters that already happened. Now I'm going to talk about today and about you. But first, I need to show you what a country looks like when it decides that earthquake survival is not optional. Japan experiences more than 1,500 detectable earthquakes every year. The entire country sits on the junction of 4 tectonic plates. Every building, every home, every bridge is designed with the assumption that the ground will move. In 1995, a magnitude 6.9 earthquake hit Kobe, Japan. 6,434 people died. The majority of deaths occurred in buildings constructed before Japan's modern seismic code. Japan's response was immediate and total. The Shinsei Kaijun Yanu seismic standard had been mandatory since 1981. After Kobe, enforcement intensified. Retrofit programs expanded. The national attitude toward earthquake preparedness became absolute. The Japanese seismic code requires calculated shear walls in every structure, anchor bolts at every connection point, steel connectors at every joint between structural members, and for larger buildings, base isolation systems that allow the structure to float above the moving ground. Forward. This is the part I didn't see coming when I started this investigation. If you're finding this valuable, subscribe. The next episode goes even deeper. Same earthquake, 7.0 magnitude. 2 houses, one built to Japanese code, one built to pre-1980 American practice. The Japanese house sways. You hear creaking, dishes fall, but the structure holds. Every connection point is reinforced. The house returns to vertical when the shaking stops. The American house shifts. The cripple wall folds at the base. The house slides 4 inches off its foundation. Gas line shears. Water pipes crack. The structure is no longer safely habitable. Same earthquake, same magnitude, same duration. One house is fine. The other is a total loss. The difference is not the earthquake. The difference is the decision about what to put between the foundation and the floor. So why didn't the United States adopt a comparable standard? The American Building Code is not federal. There is no national standard. The International Code Council updates a model code every 3 years. But adoption is voluntary. Each of America's more than 3,000 jurisdictions, cities, counties, states, decides independently what to adopt and when. The result is a patchwork. California adopted aggressive seismic requirements after Northridge. Oregon followed. Washington followed. But move east to the states on the new Madrid zone, and the adoption drops off dramatically. The state of Tennessee, sitting directly on the new Madrid seismic zone, last updated its residential seismic provisions in 2009. That was 17 years ago. The science has advanced, the code hasn't. Missouri, Arkansas, Kentucky, Indiana, the states most vulnerable to a new Madrid event, have the least updated seismic provisions. The memory of 1811 has faded. The geology has not. Before I show you the solution, I need to show you one more thing that surprised me during this research. After every major earthquake in the United States, the same pattern repeats. Homeowners discover that their standard insurance policy does not cover earthquake damage. They file claims. The claims are denied. They learn that earthquake coverage was a separate rider they never purchased. In California, the most earthquake-prone state, fewer than 12% of homeowners carry earthquake insurance. In Oregon and Washington, the number is lower. In the new Madrid states, it's essentially zero. The vast majority of American homeowners in seismic zones are completely uninsured for the one event most likely to destroy their home. Earthquake insurance costs between $800 and $5,000 per year in high-risk zones. The deductible is typically 10 to 20% of the home's value. On a $500,000 home, that's a $50,000 to $100,000 deductible before insurance pays anything. The real math. For most homeowners, the retrofit that prevents the damage costs less than 5 years of earthquake insurance premiums. Prevention is cheaper than recovery, but recovery is what the system sells. Enough about the problem. Let me show you what countries and states that solved this actually did. This is the part where the story changes. There are 3 approaches to earthquake survival in residential construction. Retrofit existing buildings. Build new buildings to a higher standard, or redesign the structural system entirely. Each one works, each one is available, and each one costs less than you think. Let's start with the one that can protect your current house, starting this month. In 1994, after Northridge, the California Office of Emergency Services launched the most comprehensive residential seismic retrofit program in the world. It's been refined for 3 decades. And it works. The residential cripple wall retrofit has 3 components. Structural plywood shear panels attached to the cripple wall studs, foundation anchor bolts connecting the wood mud sill to the concrete foundation, and steel hold-down brackets at every corner, preventing the wall from lifting off the foundation during vertical ground acceleration. The process takes a qualified contractor 2 to 4 days. Access the crawl space. Install plywood on both sides of the cripple wall studs. Drill through the mudsill into the foundation and install expansion anchor bolts every 4 to 6 feet. Attach hold-down brackets at corners and intersecting walls. The cost, $3,000 to $7,000 depending on the size of the house and the height of the cripple wall. For most California homes, the number is around $5,000. And here's what most eligible home quake brace and bolt program, a partnership between the California Earthquake Authority and FEMA, provides grants of up to $3,000 per house for seismic retrofit. If your home was built before 1979 and has a cripple wall or unbolted foundation, you may be eligible. The process: visit earthquakebracebolt.com. Enter your address. If your zip code is in an eligible area, you register, receive the grant authorization, and hire a FEMA-certified contractor to perform the work. The net cost to the homeowner can be as low as $0 to $4,000. The program has existed since 2013. In 13 years, fewer than 30,000 homes have been retrofitted through the program. 30,000 out of more than 1 million eligible homes in California alone. 30,000 out of a million. 3%. The money is there. The technology is proven. The contractors are certified. What's missing is awareness. Most eligible homeowners have never heard of the program. That sentence bothers me more than anything else in this story. The solution exists. The funding exists. The awareness doesn't. Now, let me show you the construction methods that survive major earthquakes without any retrofit needed. Insulated concrete forms. ICF. Walls built from interlocking foam blocks that are filled with reinforced concrete. The result is a monolithic concrete structure, continuous, seamless, with steel rebar running through every section. Seismic force distributes uniformly through the entire structure. In shake table testing, ICF homes have survived simulated earthquakes of 7.5 magnitude with 0 structural damage. Not minor damage, 0 damage. The foam forms flex just enough to absorb energy without cracking the concrete core. An ICF home costs 10 to 15% more to build than conventional wood frame. Over a 30-year life cycle, factoring in energy savings, insurance reductions, and 0 earthquake damage, it costs 40 to 60% less. The math works. The market hasn't caught up. Cross-laminated timber, CLT, is the other breakthrough. Layers of lumber bonded at right angles into solid structural panels. The natural flexibility of wood combined with engineered metal connectors provides ductility, the ability to bend without breaking under seismic load. Japan has been building with CLT since the early 2000s. 8-story CLT buildings in Tokyo's seismic zone. The material is light, reducing seismic inertia. It's strong, exceeding concrete's performance per pound. And it's renewable. The map of solutions matches the map of risk. Pacific Northwest, ICF or CLT for new construction, immediate cripple wall retrofit for existing homes. California, aggressive retrofit plus ICF for replacement housing. New Madrid zone, anchor bolts and foundation connections as an immediate first step. Hawaii faces a double threat, earthquake and tsunami. Elevated ICF construction addresses both. The mass resists seismic force while the elevation allows tsunami surge to pass beneath. Here's something that surprised me. Some of the oldest buildings in seismic zones, 500-year-old adobe and rammed earth structures, have survived earthquakes that destroyed modern buildings around them. The reason is physics. Mass plus thickness equals inertia. The earthquake moves the foundation faster than the massive wall can respond. Less seismic energy transfers into the structure. The building is too heavy to shake. It's not elegant engineering. It's brute physics. And it works. Now, how to find out if your house is vulnerable? 3 questions. 1. Was your house built before 1980? If yes, it was built before modern seismic codes were adopted in most jurisdictions. 2. Do you live in California, Oregon, Washington, Nevada, Utah, Alaska, Hawaii, or the New Madrid zone, Tennessee, Missouri, Arkansas, Kentucky, Indiana, Illinois, Mississippi? If yes, you're in an active seismic area. That's a cripple wall. If you answered yes to any of these, visit earthquakebracebolt.com and enter your address. If you're in California, you may be eligible for a $3,000 retrofit grant. If you're outside California, search for your state's seismic retrofit incentive program. If you're not in a traditional seismic zone, verify that your municipality has adopted the current International Building Code. The IBC is updated every 3 years. Many jurisdictions lag by a decade or more. Knowing your local code version is knowing your home's baseline protection level. Knowledge doesn't build a house, but knowledge tells you when to hire someone who can. Let me tell you what really disturbed me during this research. In Caracas, the buildings that collapsed didn't collapse because they were old. They collapsed because someone, decades ago, chose not to spend an additional $40 per square meter to add adequate steel reinforcement to the concrete. In Northridge, 57 people didn't die by accident. They died because decades of insufficient code allowed cripple walls to be built without shear panels. The solution existed before the earthquake. The requirement didn't. And today, in San Francisco, 140,000 families are sleeping in apartments that engineering already knows will collapse in a major earthquake. The retrofit exists. The money exists. The awareness does not. Every house has the glass floor is the specific point where your house was built to the edge of the code and stopped. Not because the engineer didn't know what was beyond that line, but because what was beyond that line cost more. The glass floor is the gap between what we know how to build and what we choose to pay for. The question is not whether an earthquake will find the glass floor of your house. The question is what you will do with this information now that you have it. The earthquake doesn't build the glass floor. The earthquake just finds it. Venezuela showed us a glass floor in 40 seconds. Northridge showed us one in 1994. The engineers show us one in every seismic assessment they write. The glass floor is always there. We just don't look down. Let that sit with you for a moment. If you live in a seismic zone and your house is pre-1980, there is an action you can take today. Not next year. Today. Traditional seismic zone, check the map. The New Madrid zone covers 8 states in the central and southern United States. Human memory forgets earthquakes. Geology does not. We've covered hurricanes. We've covered foundations. We've covered walls and roofs. Now we know that every natural threat has a specific vulnerability engineered into the design of your house, not by accident, but by choice. The common thread across every investigation on this channel is the same. The gap between what we know how to build and what we actually build is the most expensive distance in American construction. In the comments, tell me. What's the biggest seismic risk in your area? And does your city have an updated building code? I'll respond. The next episode in this series looks at what happens when fire meets wood frame construction, and why the Los Angeles wildfires of 2025 were exactly the warning that every American homeowner needed to hear. If this type of investigation matters to you, subscribe. We do this every week, and every episode changes how you see the place you live. 920 people died in Caracas on June 24th. Most of them were inside buildings that engineers had been warning about for years. The warnings were documented, the recommendations were published, the retrofits were costed, they weren't implemented. Not because the technology didn't exist, not because the money wasn't available, but because the urgency wasn't felt until the ground started shaking. You're feeling the urgency right now. You felt it when you saw Caracas collapse. The question is whether you'll still feel it next week, when the news cycle moves on and the ground beneath your house is quiet again. This house survived, not because it was lucky, because it was built differently. The technology existed for every house on this street. Only one owner chose it. The choice is available to you right now. The retrofit, the insurance, the information. Everything I've shown you in this video is actionable. Behind every building that collapses, there's a decision that was made when nobody was watching. Behind every building that stands, there's one too. The glass floor is invisible until it breaks. Now you know where to look. Resources in the description below. Earthquake, brace
The
and hold.
2025
Check your
wildfires left nothing but
USGS
ash
earthquake
and these
hazard
haunting
maps.
skeletons.
Find your risk level.
Today,
FEMA
our
seismic
investigation
retrofit
into the
guidelines,
cause begins here.
P1000 series,
Same
free to
force.
download. International Code Council.
Different
Check
engineering.
whether your city has adopted the current building code for Venezuela. Links to verified disaster relief organizations in the description. The people of Caracas need help now. Every episode of Built into America is linked below. Start anywhere. Each one
The
changes how you see
2025
your home.
wildfires
The ground
left
beneath
nothing
your
but
house is
ash
quiet right
and
now.
these haunting
It
skeletons.
won't always be.
Today, our investigation into the cause begins here.